Assalamualaikum and good afternoon everyone. Today we will presenting about the National Bank ATM system and we are from class CDCS2594E. This is our the group members. First, my name is Siti Zulika Binti Osman and the meeting number is 2024-803-848. For the second, name is Karya Adana binti Khairul Masidin and the message number is 2024-649-252. For the third is Sheikh Muhammad Kamal bin Naim bin Sheikh Muhammad Kamsah. For the message number is 2025-178-587 and the four members is Isha Yasirah binti Ahmad Sofian and the message number is 2025-195-681. For the introduction, our project is called the National Bank System. It is a modern ATM simulation system designed to facilitate and streamline daily digital banking operations for the user. This application is developed entirely using Java Swing for the graphical user interface while integrating core object-oriented programming principles. It's including abstractions, inheritance and polymorphism to handle our banking logic behind the scenes. Visually, the system features a premium model charcoal grey and gold design layer, giving it a realistic professional, minimalized banking experience that's similar to a real bank ATM interface. We are a team of 4 members and each of us focus on different parts of the system. I will start by introducing my own contributions. For the members 1 is me. My name is Siti Zulaika Binti Osman and I was the UI designer responsible for the main window of our ATM system built in ATM frame.java. My coding task was to build the external structure of the ATM interface using Java Swing and to set up the charcoal grey and gold theme that runs throughout our whole application. I align my work with 4 lab files from our lecture. First, my frame.java. I use this to set up the initialize our main structural window, the JFrame, including the title, fits, window size, and centering it on screen when the apps launch. Second, border layer example.java. I use border layer to position the bank brand header at the nodes region and the operational menu at the center region. For the third, flow layer example.java. I use flow layer to align the base button like the login button in the source panel area. 4. Label test.java. I use JLabel components to cleanly display instructional text on screen such as the bank name, subtitle and the username and PIN number field label.
Moving on, so I will be presenting about the PinPad panel implementation, which we use the GUI frameworks, which I utilize a JPanel configure with a grid layout 4x3. This was chosen to perfectly mimic a realistic physical ATM keypad structure with a uniform button arrangement. Second, to maintain design consistency, I customize the component color using Java color class. Third, for the interaction logic, I implemented model lambda expression inside the action listener, which allow the keypad to communicate directly with ATM frame. When the user click the numeric buttons, the input is immediately sent to the JPassword field in real time. Most importantly, I integrated input security validation, which the code strictly restrict the input field to a maximum of 4 digits to match our test data profile. So if a user tries to type an extra digit, the system safely reject the input and trigger a warning. Furthermore, by clicking the enter on my keypad, automatically execute the do click method on login button, so it triggered the backend authentication smoothly.
Okay, I'm gonna continue on my part, which is I'm focusing on backhand logic and object-oriented programming structure. My responsibility is to design the mathematical formulas, balance calculation logic, and the overall OOP framework for the ATM systems. First, we use abstract parent class called account Java, which store essential user information such as account name, account number, and balance. Next, through subclass inheritance, the saving account Java class inherits properties from the parent class to handle specific rules for saving accounts. We also apply polymorphism by overriding the withdrawal and deposit methods. This allows the system to dynamically manage account transitions in a logical and flexible way. Finally, we implement data structure like array lists or native arrays to securely store and manage valid user account during runtime. This backend structure ensures that the ATM system runs smoothly, maintains account balance calculations, and protects user data integrity.
Next, I will present my responsibilities as number 4, which focus on data and logic management. First one is I implement a secure file-based storage system to manage user accounts and transaction history. Second, I develop a robust algorithm to handle transaction, processing, and real-time balance updates. The third one is I engineer the automated receipt and statement generation features for the system. Lastly, I implement a system logging and error catching mechanism to prevent data loss.
Now, I will briefly explain the 5 core features of our National Bank ATM application. First is secure authentication. It verifies the identity via unique username and PIN database matching before granting main menu access. Second is interactive PIN pad and validation, which engineer 4x3 graphical numeric panel for mouse click input. It strictly enforces a 4-digit PIN boundary limit to enhance security. Third is dynamic deposit management, which handle real-time fund increment, ensuring the deposit amount is strictly more than 0 ringgit. Fourth is a conditional withdrawal, which process cash deduction based on account rules, such as maintaining a mandatory minimum balance for 50 ringgit for saving account. And then finally, automated receipt printing, which generate a structure.txt file detailing the account balance, transaction log, and timestamp. In short, all of this module communicate smoothly to form a secure ATM system.
Now, I will present a quick simulations to demonstrate how the interface works. Here is our login screen. As you can see, the header is at the position at notes with our bank logo and instructions. For the input, field is sit at the center and the login button is aligned at the source. Now, I will log in using one of our test account. The username is Aisha21 and for PIN number, we can type or we can use the PIN pad panel also. So I will input the PIN number is 2434. And then I can log in. As you can see, the system successfully validate the credential and switch to the menu screen using the card layout. Now, no new window opens. It's a smooth transition within the same screen. Here on the menu screen, you can see the welcome message showing the account holder name Nurul Aisha and the current balance is RM5250 ringgit. displayed at the top in our gold accent bill color. Below that, the transactions buttons, deposit, withdraw, print statement, and the logout are arranged using the grid layout following the same clean, consistent structure as the rest of the interface. Let's conclude the simulation of my part. Now I will pass it into Kyra Adana to demonstrate the keypad interface and the pin validation. Now I will present.
As I mentioned before, for the feedback panel.java class that I developed, I structured the implementation into three core parts, which first is a layout with grid layout 4360 to automatically construct a uniform of 4x3 banking keypad. And then for the object communication integration, we use the Java Lambda expression, which is PF pin and also button login. Next is security input validation, which I implementing a strict boundary check using if current text dot length is below than 4. So if a user attempt to use like 5 digits, the system block the input and immediately flash a J option pane warning dialog.
Okay, moving on here. I'm gonna explain about ATM account system in the Java. The system is built using object-oriented programming principles such as abstraction, inheritance, and a method overriding. It consists of an abstract class account and two subclass, saving account and current account. Okay, over here we have uh, the the account, which is the abstract class. Over here is declared as an abstract, which is it cannot be in station directly. Instead, it serves as a blueprint for different account types. It also defines common attribute like username, PIN, owner name, account type, and balance. It provides methods such as validate, PIN, get balance, and deposit. These are shared across all account types. Two abstract methods will be withdraw and get interest rate are left undefined, forcing subclasses to implement own rule. Okay, I'm gonna continue on the subclass, which is having savings account. Uh, savings account extends account and set its type to saving account. The withdrawal method ensures that the balance never drop below 50 ringgit. This simulates a minimum balance requirement. Its override get interest rate to return 2.5%, reflecting typical saving account interest. Okay, last, the subclass here will be the current account. Current account also extends account and sets its type to current account. Its withdrawal method allows withdrawals as long as the request amount does not exceed the balance. No minimum balance restrictions. It overrides get interest rate to return 1%, which is lower than saving accounts, reflecting real-world banking practice.
It generates a timestamp receipt.txt file for every transaction using PrintWriter and can generate account statement on demand. To ensure reliability, all file operations are wrapped in try-catch blocks so the app remains stable even if a data file is missing or corrupt. Finally, the implementation demonstrates polymorphism as it seamlessly reconstructs either a saving account or current account object from a shared file format.